Welcome to The Explainer. Let's just dive right in because today we are tackling an incredibly urgent issue that is facing nearly every modern organization right now, the cloud data crisis. In a world where data generation is just absolutely exploding, enterprise cloud archiving is no longer just some routine IT housekeeping chore. Honestly, it has become a critical, high-stakes strategic capability. 80 to 200 times. Let that sink in for a second. That is the astronomical cost premium you're paying to keep inactive historical data sitting around in high-performance in-memory databases or active analytical warehouses compared to just using standard cloud object storage. It's essentially like renting a luxury penthouse suite just to store boxes of your old tax receipts. We all know operational costs are escalating, but this massive cost differential, that is exactly why offloading inactive data is an absolute economic imperative. But this brings us to a huge, often hidden danger. So you might be thinking, is cheap cloud storage the solution, or is it a dangerous trap? The elasticity of cloud computing creates this really powerful illusion of infinite capacity. Storage, like Amazon S3 or Azure Blob, is so inexpensive, you might naturally think, hey, let's just dump all our old data in there and forget about it. But as we're about to see, treating archiving merely as a passive, cheap storage dump is a direct path to serious enterprise liability. Section 1. The hoarding fallacy. When cheap storage becomes a liability. See, uncurated data hoarding transforms your cheap storage into a toxic digital landfill. Just look at these four immense risks. First off, you've got the legal discovery blowout. If you keep everything forever, e-discovery literally forces your legal team to sift through petabytes of irrelevant garbage, which drives up costs exponentially. Second, privacy surcharges. Under regulations like GDPR, if you can't find and erase personal information hidden in unstructured object dumps, you are facing massive fines. Third, and this is a big one right now, dark data poisoning. Feeding stale, unmanaged historical context into your AI models causes dangerous context drift and hallucinations. And finally, storage metadata explosion. Retaining billions of tiny, unmanaged files drives up API transaction costs and absolutely kills system performance. So we have to shift the paradigm here. On one hand, you have traditional offline archiving. Think magnetic tapes, closed proprietary formats, and taking days or even weeks just to restore a single backup. It's essentially dark data. But contrast that with the modern, governed archive. This lives on elastic cloud object storage, uses open, self-describing formats, and most importantly, it's instantly cataloged and queryable in seconds. It brings your historical data back into the light, completely independent of those expensive active databases it came from. Section 2. Rethinking the enterprise archive. Separating brains from brawn. Okay, so the brains of a modern archive is what we call the control plane. And this is where the real enterprise value lies. The control plane stores no raw business data itself. Instead, it purely manages the metadata and the governance. It includes an enterprise data catalog to track object schemas and glossaries, a policy and security engine for granular access control and masking, a retention engine that orchestrates legal holds, and immutability tracking to cryptographically prove that your data hasn't been tampered with. Without this control plane, your cheap object storage is literally just a dumping ground. And that brings us to arguably the most critical feature managed by that control plane, defensible deletion. A modern archive must automatically delete data just as efficiently as it stores it. This means systematically purging expired data based on strict business retention schedules, complete with verifiable audit logs. Getting rid of obsolete data on time is exactly how you proactively eliminate those massive legal and privacy liabilities we were talking about a minute ago. Let's zoom out and look at the bigger picture for a second. Notice how data ages gracefully here? It starts out as active data in a high-availability, real-time database. Then, as it cools, it becomes warm data for weekly reporting, drops to analytical history in a data warehouse, and eventually transitions to the governed archive where it's accessed maybe just once a year. From there, it might go into a deep archive for strict legal holds, and finally, at the very bottom of the life cycle, it reaches defensible deletion, meaning complete cryptographic erasure. Understanding this flow is absolutely essential to mastering your architecture. Section 3. How modern archiving works. Querying cold data in seconds. So how do we actually pull this off? Well, the foundational magic of this architecture relies on open storage formats, like Apache Parquet. Parquet is a column-oriented format that dramatically shrinks massive datasets. We're talking 4 to 8 times compression over raw text. But the real genius here is that it embeds a self-describing schema directly into the file footer. That means the archive preserves the semantic context entirely on its own, completely independent of the live application that originally created it. Now combine Parquet with serverless direct query, and you unlock some incredible capability. Embedded serverless engines, think DuckDB or AWS Athena, allow you to run complex SQL queries directly against those cold object storage files. This bypasses the active, expensive database infrastructure entirely. You don't have to rehydrate the data or pay for standby compute clusters just waiting around for a question. You just search and you find what you need instantly.
Section 4. The true cost reality. TCO is more than just storage.
Listen, if you're only looking at the base storage slice of your total cost of ownership, you are walking straight into a budget trap. You must account for API and request surcharges, especially during high-volume ingestions. Then there's retrieval and egress fees. Pulling data out of a cold tier or sending it across different clouds can incur massive penalties. You've also got compute processing for the extraction pipelines and the catalog and security overhead we discussed earlier. A true, reliable business case models all 5 of these components, ensuring you don't accidentally reverse your savings through hidden traps.
Section 5. A roadmap to success. Crawl, walk, run, plus.
To make this concrete, here is a highly pragmatic, phased approach for enterprise decision makers. You start with Phase 1, crawl. Target the largest, oldest database tables for immediate batch extraction to get some quick storage relief. Next is Phase 2, walk. This is where you deploy that vital governance control plane and set up your retention policies. Then we hit Phase 3, run, enabling federated querying so users can search the archive themselves and fully automating that defensible deletion workflow. Finally, Phase 4, plus. This is the cutting edge, where you optimize for zero egress environments and feed this perfectly clean, curated historical context securely into your generative AI systems. If you want to distill this entire strategy into a single North Star, it is this. Data shall be stored in the lowest cost tier appropriate, governed by a centralized control plane, and systematically purged upon lifecycle expiration. This isn't just about saving a few bucks on IT storage. It's about elevating your data lifecycle, retention, and disposition into a formal, cross-functional enterprise discipline. Which leaves us with this final, lingering question to consider. I want you to look at your own architecture right now. Are you building a governed enterprise archive or a toxic digital landfill? I highly encourage you to evaluate your own organization's data lifecycle practices today, because the longer you wait, the more expensive and risky that landfill gets. Thank you so much for joining me for this explainer, and I hope this provided you with some clear, actionable insights into mastering the cloud data crisis.